All right. So this is perhaps the most practical section of the year. Everything that we've been doing has been leading up to this unit. And with this unit, we will complete the first semester. Okay. And there's only two parts to this unit, today and tomorrow. So it's actually, if you remember Reagan's story, then you should be fine. Reagan's story. Reagan. This young lady's name is Reagan. If you remember Reagan's story, you should be fine. What is her story? Well, Reagan's doing pretty well in chemistry. She seems to get it. So goes through Christmas, comes back, and next semester is kind of different. I consider next semester stuff to be easier than this semester. Of course, we will just be adding on to this first semester, so Reagan knows that she can't forget what she learned this semester. Um, but she does really well next semester. Actually, by the end of the year, she's saying, Mr. Moreno, I know that it's a little tougher for me to go to AP chemistry from CP, but do you think I can do it? And I say, yes, I think you can. So we get her into AP chemistry next year with Coach Hodge, and she does a great job. She just gets chemistry naturally. So she actually goes to she not auditions. She tries to get into Georgia Tech. She applies to Georgia Tech and engineering school because she's decided she wants to be a chemical engineer based on this lecture. She decides that she wants to be a chemical engineer and she gets in. Okay, now what do I tell her in this lecture? Engineering, chemical engineering and chemistry are actually two different beasties. You have a much better job uh, opportunity for chemical engineering than you do for chemists. Why? Because chemists are usually in the lab, learning stuff, creating stuff. Okay? And usually a large company will hire two or three chemists because they just keep them in the lab doing stuff. And as long as they're learning how to do new stuff, they get rehired. So we don't need that many chemists in the world. Chemical engineer, their job is to take the stuff that chemists learn and apply it to large scale. So a company like DuPont may hire a small fleet of chemical engineers, and their job, they are sent to different factories with orders to have this product made in large amounts. Okay, a chemist is going to produce grams. A chemical engineer is going to produce tons. So the downside, first of all, chemical engineers will make more than chemists. The downside is, if you think about it, a company will hire you to go and get something started. Once it gets started and it's producing tons, they don't need you anymore. So they fire you. They don't fire you. You are contracted to do a job. Your job finishes and you're done. Okay, so the downside to engineers is that they tend to be more transient. Instead of working in a lab forever and ever, they will tend to be moved from factory to factory. Okay, so Reagan goes through Georgia Tech, loves it, graduates with honors in chemical engineering. And because she graduates from Georgia Tech, she is hired by DuPont off of Atlanta to be an engineer for them. Okay, great starting job. Usually starting pay is 80 to 100,000. Okay, Reagan, I'll never make $80,000 teaching. So that's not bad. Unfortunately, you're starting out in Georgia where you have a 2-year project. Okay, so she does her 2-year project very successfully. Her boss is very happy with her. The advantage to working for DuPont is that usually they hire you and they keep you employed. They'll just move you from factory to factory. DuPont is a international company that has factories all over the world and all over the country. So they can afford to hire a fleet of engineers that they move from place to place. If you're working for a smaller company, then they'll probably let you go and you have to go and find somewhere else to work. That's why places like DuPont and Eastman are lucrative places for engineers to work because they have job security. So, 2 years into the job, Reagan, your boss comes up to you and says, "We are very happy with your work. The factory is going very well. We need your expertise near New York City, suburb of New York City. Are you willing to move?" Okay, Reagan, you need to understand you may love Atlanta, but when you're an engineer and your boss says, "Are you willing to move?" they're not really giving you a choice. It's either move or you're fired. Okay, so they're just being nice when they say, "Are you willing to move?" Nevertheless, you say, "Yep." Now, don't be too enthusiastic because this is the South. This is Atlanta. And you've grown used to every morning driving by Chick-fil-A and getting a different breakfast item because you love Chick-fil-A. Okay? You're going to the suburbs of New York City, which you may not need to live in Manhattan, but it doesn't matter. If you're living anywhere near New York City, what you're used to paying in Atlanta will not be what you pay for a Chick-fil-A. If you can even find a Chick-fil-A, it will not be what you're used to paying because of the cost of living difference. Here near Atlanta, she has a very, very nice apartment for $1,200 a month. Very nice. 3 bedrooms, 2 baths. I mean, and she has it all to herself. Very nice. Okay, because she can. She's making $80,000. Okay, so she gets online and she starts looking for apartments near the factory. Okay, for a 1 bedroom, 1 bath, living room, that's it, $3,000. Okay, so they will bump up your pay a little bit, but the fact is, this is not a good financial move for you because the cost of living difference is so much, the cost of living is so much greater over there. This is actually probably a pay cut for you. Okay, Atlanta is cheaper. New York City is just going to be far more expensive. Everything you pay for, you'll be paying twice as much, and you're not making twice as much. So, but Reagan, you are living near New York City. You like it? I mean, there's pluses and minuses. I think Reagan's going to be happy. Now, that's the end of Reagan's story for today. But tomorrow, very exciting things are going to be happening to Reagan. Okay? Do you know what the name of the Pittsburgh Steelers quarterback is? What's his nickname? Big Ben. Guess where you're going next? London to see Big Ben. That's tomorrow's episode. That's tomorrow's episode. Stay tuned. Okay, now if you're wondering, and Freddie, I know you're new with me. They're not wondering this, but maybe you're wondering, what the heck is he talking about? I teach using metaphors, and a lot of times they're trying to figure out what is he talking about, and I usually bring it back around and help them understand something through the use of a metaphor. Okay? And that's exactly what I was doing today. Early chemists did not care much about measurements. They only cared about results. Remember that for most of chemistry history, they were trying to figure out how to convert copper into gold, alchemy. Okay, the end result was the most important thing. It wasn't until the 1700s that we finally got a hold of a scientist that was very good at measuring before and after. Who remembers the scientist from the 1700s who came up with a very important law that really got chemistry going? Yes. Yes, you pronounced it incorrectly, but that is correct. The answer to question number one is Lavoisier. Yes, you should. Lavoisier. It's French, so who knows which one of these letters should be pronounced?
You learn Latin, you remove the Spanish.
Okay, thank you. Calculations made from these measurements help us to see the relationships in chemical reactions and to truly understand chemical changes. It helps Reagan, it's going to help Reagan control how much she produces. Believe it or not, she's going to learn a lot of advanced chemistry, but most of what she is going to use once she gets into the real world is what I'm going to teach her tomorrow. It helps us to calculate the exact quantities of substances in a reaction and predict the amounts of each product. This is very practical. Why? Because for the time being, here in America, we are capitalism. We are a capitalistic society. And the most important thing in a capitalistic society is making money. Okay? Her job is to make the maximum amount of stuff that her boss wants for the minimum amount of money. Who here works in a fast food restaurant? Where do you work? Freddy's. Okay. You've had the same manager for a while? Was he or she fired or they just transferred? Ah, okay. If they were fired, then that could mean that they're very bad at what I'm teaching you. Okay. If they're there still, it means that they're very good. What does that mean? Well, your boss has to order your ingredients, has to order the lettuce and the tomato, and order the buns and order the meat. And unfortunately for him or her this year, because Freddy's is new, they don't really know, they don't have much history. So they have to go on the history of other stores in similar locations. So we're coming up on the holidays. How many hamburger buns should they order? How many hamburger patties? How much lettuce? How much tomato? What happens if they don't order enough? Cassidy, what? And so you lose business. You lose money. What happens if they order too much? Because if it's not used, it goes to waste. Okay, so I dare say that if you were to sit down with your manager and talk to him or her, she would probably explain to you, that they probably have some kind of models or some kind of equations to help her be able to order very accurately, because you want to order very accurately. You want what you bring into the store to be completely used, because if not, it is wasted, and waste is money loss. And that's very, very bad for a store. The key to all this is coefficients. Three things these coefficients can tell us. Remember those big numbers we use to balance equations. And I warned you, when I taught you how to balance equations, I warned you that balancing equations was going to be very, very important. And it's about to be. Here is the equation we used a couple of weeks ago when we did the rocket ship lab. 2 hydrogens plus 1 oxygen yields 2 waters. What do those big numbers mean to us? Well, they could mean the molecules. 2 molecules of hydrogen plus 1 molecule of oxygen will form 2 molecules of water. Okay? Do you think that when Reagan's a grown up working as a chemical engineer, she's going to be worrying about molecules? No. She's going to be dealing with tons of material. Molecules is not very practical. What else could it tell us? Because when I taught you the mole, I taught you that 1 mole of any gas was going to equal 22.4 liters. Since a liter of one gas has the same amount of stuff as a liter of the other, you could say liters. 2 liters of hydrogen, when you mix it with 1 liter of oxygen, will form 2 liters of water. That's a little more practical, right? Because maybe she won't be asked to create tons. She may be asked to create kiloliters or something. What mole? Yeah. Okay, a mole of hydrogen is the same number of things as a mole of oxygen. So they are analogous. So we can say 2 moles of hydrogen will form with 1 mole of oxygen to form 2 moles of water. Now, the one unit that these coefficients cannot tell you is what unit, which is very practical. Okay, we've used moles, which is not very practical. Liters, which is molecules, is definitely not practical. What unit have we used a lot of? Grams. Grams. Okay? Now, to be able to use this equation using grams is not possible because a gram of hydrogen is a different number of things as a gram of oxygen. It would be like bringing home some British pounds from a trip to Great Britain and giving it to Cassidy at Freddy's in order to pay off your check. It ain't going to work. Cassidy will give you her pleasant smile and say, no, we need American currency. The one currency that all chemicals will take is the mole. But chemicals will not take each other's grams, which is the biggest problem that we will have to deal with tomorrow. All right. So for this one, if Reagan is asked to move from Atlanta to New York City, will she be able to use the same currency that she's paid with in Atlanta? Okay, so I want you to use that analogy to be able to anticipate how much she is going to have to pay in the next city based on the cost of living. Okay, so it's only going to take 2 questions. It's that easy. Here's the first question. This question is incomplete because I have to give you something else. The something else I have to give you with all of these is a balanced equation. You do not even have to balance it yourself. Okay. So you don't have to copy down the question because the question will be there tomorrow when I give you the notes. You do need to copy the balanced equation. What are you given? 5.98 moles of water. Okay. So this is basically what this question means. She is used to paying $6 or 6 moles in Waterland or Water State. She is being moved to oxygen state. She wants to know how much is that going to cost her there. If she's used to spending $6 a morning at Chick-fil-A, she would like to know how much is it going to cost her to go to New York City. This is actually something that Google could do for you. There are websites where you Google, where you go to the website, you tell them where you're living, you tell them where you're going to be living. I bet you anything that Freddie's dad did this, and he was very, very pleased, I'm sure. And it'll tell you if you're going to spend $1 in Atlanta, it's going to cost you this much in New York City. There are websites that will do this for us. In chemistry, we don't need a website because all we need is the balanced equation. What does this balanced equation tell us? It tells us that if you're used to spending $2 in Waterland, you will have to spend $2 in hydrogen land, but only $1 in oxygen land. Okay? So, what does this look like as far as doing the actual math? Here we go. Got to get rid of moles of H2O, need moles of O2. Where do we get those numbers from? The balanced equation. 2 to 1. The answer is 2.99 moles of O2. How did I do that? I divided 5.98 by 2. It's that easy. It's that easy. Any questions? So put down what you're given and then use the balanced equation to know what the cost of living difference is. Let's do this one. I've got to give you the balanced equation. Let's see, 3, 4, 5. Didn't mean to do that. C. What are you converting from? What state are you moving from? C3H8. What state are you moving to? Where do we get those numbers? 1, 2, 5. Okay. I'm going to post this video in the next few minutes up online. What's the answer? $4.30 times 5. I prefer somebody to use a calculator. All right, I'll post it so that you can watch it again, see how easy this is. Do the homework. Do the homework.